Hi, everyone. We've set up this Being an Engineer podcast as an industry knowledge repository, if you will. We hope it'll be a tool where engineers can learn about and connect with other companies, technologies, people, resources, and opportunities. So make some connections and enjoy the show.
And the success of the process was predicated on getting a 12-year-old girl to do something she doesn't want to do for 20 hours a day for 2 to 4 years. You're not going to win that battle. And the only way you're going to do that is really hack and rethink that experience.
Hello and welcome to another episode of the Being an Engineer podcast. Today we're talking with Scott Summit, who is a senior industrial designer with decades of experience in innovation, design, and entrepreneurship. Scott started a company doing 3D printing for exoskeletal fixation that was ultimately acquired by 3D Systems, where he then ran a skunkworks style team exploring just how far the industry can push 3D printing. Scott, thank you so much for joining us today.
Oh, thanks for having me. I'm looking forward to this.
All right. So what made you decide to become an industrial designer?
I think a lot of industrial designers end up in that path the way I did, which is that we don't have the attention span to be an architect. We want to be a little more focused than a fine artist, and we don't have the sense of rigor to be an engineer. So, process of elimination, that puts us straight into industrial design.
I think you're being a little bit humble, Scott. I've now read several things that you've worked on, and I think that you have, at least it seems from the outside, that you have quite a bit of call it design rigor. At least that's what it seems like to me.
Design is fun at the end of the day. It's what I did as a kid. I just didn't know it. I did it informally with cardboard and duct tape. And now when I do design of any kind, it is a rigorous operation, but it's just a lot of fun as well.
Yeah. Do you remember any of the cardboard and duct tape designs you worked on as a child?
Yeah, well, I grew up kind of alone up in the hills, and so I inherited this great set of tools from my granddad. And so I had this, early 20th century tool garage and built everything.
Wow.
I made miserable messes, but that was childhood for me.
What kind of tools were they that you were using?
These are these great old wooden handled wrenches and hammers, very clumsy stuff, planers and things like that. Simple stuff, but there was a beauty in the over construction of it all. No plastic, all just heavy cast metal, and I love that. There's a real tactility to those products.
Yeah, that's great. Well, a lot of the we'll kind of get into some of the things that you've done, but one area where you spent quite a bit of time is this area of orthotics and prosthetics. And from what I've seen of your work, they're designed with very, very beautiful organic shapes. It's definitely not these over-engineered, bulky tools from the early 19th century that you used growing up. The designs that you've worked on are, again, very beautiful and organic. What CAD system or systems have you been using to create these shapes?
Yeah, that's a sticky one because I started using Pro E at Pro 3 or 5 or something like that 30 years ago. And so it just became my lingua franca, and I never got around to evolving to another CAD app. It's exactly the wrong CAD application for what I do, which is highly sculptural stuff. A lot of going to Unity and to Unreal, a lot of scan data going in. Pro E is the perfectly wrong software, and so actually, as of this week, I decided to not renew my license, and I'm switching over to Autodesk Fusion 360. It makes a lot more sense for what I do. And actually, in my team at 3D Systems, I made sure not to hire anybody who was like me. I hired guys who were really good at Rhino, 3ds Max, Maya, Modo, all the other tools, and I wanted nothing to do with 3D System or Pro E in my lab.
But you figured it out, I guess. I mean, over 30 years you were using Pro E. I guess it is capable, if not the most efficient tool to create those shapes.
I could beat it into submission often, and that's about the way it felt. It felt like we were, if we were people, we'd be yelling at each other, not working collaboratively. And so a lot of times I'd go down these blind alleys and just get to these points where Pro E just had nothing to offer. And so there I would have to send the work out or hire somebody who could use 3ds Max or Maya. Because the shapes, when you go down that path and you're saying, okay, like we're going to do a scoliosis brace, you start with a 3D scan of a girl's torso, and then you have to clean up that scan. Okay, that's done in Geomagic or a mesh mixer. And then you have to create surfaces out of it. Of those surfaces, you have to punch holes in it, the fenestration that lets the girl's skin breathe. So that might be, several thousand holes. And they can't be round because of interesting geometry. So those might be elliptical or algorithmic. And then you have to offset that with a thickness. Now, every one of those several thousand holes has to have a radius on it because otherwise it will be too sharp against the girl's body. So you try to do that in solid modeling, and you've got a really ugly month ahead. In 3ds Max, that's about an afternoon. So it was after I built those braces, I just realized I have to just hire 3ds Max guys.
Interesting. Yeah. Like Rhino was kind of the answer I was expecting to hear, not Pro E for sure. I mean, Pro E, SolidWorks, they're kind of the same thing. I don't know Rhino at all, but I would expect that someone who creates works of art like you have is in a program like that. I don't know 3ds Max very well, but I assume it's similar to Rhino.
Yeah, they seem to be similar. I don't know how to use any of them, but my team did, and so I was always looking over their shoulder.
And so you're moving to Autodesk, what was it, 360?
Yeah, Autodesk Fusion 360.
Fusion 360?
From what I can tell, Autodesk Fusion 360 seems to have more of a direction into the future because they are looking at really nice seamless integration of topology optimization, of getting into virtual reality and really integrating that well. And then connecting with some of the other softwares like Gravity Sketch for virtual reality, with Unity and with Unreal, which are becoming more and more significant in design and development environments.
Okay, so you decided on Fusion 360 not necessarily because it has all these brilliant 3ds Max Rhino-like organic sculpting tools, but more because of the future of what they're promising, getting into the virtual reality and things like that.
There's that, and also I had to steer away from Pro E. PTC is very. Let me start that again, please. PTC uses VARs for everything that it does as far as sales, and that grew old after a number of years, and I was really done with working with VARs to install their software, to pay VARs constantly for whatever VARs felt like charging me. And I never really saw the VA out of VAR. I just saw the R. And so I was pretty sick of that by the time I was done with it.
Well said. Well said. Okay. Well, a lot of the people who listen to this podcast, not all of them, but a lot, are mechanical engineers. So what should mechanical engineers, mechanical design engineers know about working with industrial designers that will allow them to work more productively together?
I think that's a really important question that maybe doesn't get explored enough. In Silicon Valley here, it has such a rich design scene that everybody knows how to work with everybody. And then usually everybody has either seen each other at Burning Man or, out of cocktails in the evening. So it's a kind of a happy family between the mechanical engineers, the product designers, and the industrial designers. What works really well is that a lot of the PDME people come out of Stanford here, and their program especially focuses on working with industrial designers specifically so that they don't second guess what the ID guys are trying to do. They don't challenge it and they don't undermine it. They try to work very synergistically with them. And that, when you're doing consumer product, like the work I did for Apple and Silicon Graphics and such, that's really important that the ID person doesn't have to justify what they're doing and have to argue all the time, because that's really not what we went to school to do. And I think on the other side of the equation, the other half of that synergy is the industrial designer has to know a lot about the challenges that are going to be faced by the ME person, because they can't throw out shapes that have undercuts or varying wall thicknesses, or they really have to understand their injection molding characteristics or CNC or whatever the downstream process is. They have to know that very well. And if they don't, there will be surprises in the process, which will be time consuming and expensive.
Going back to the complex shapes that industrial designers might create as part of their designs, especially since you used Pro E for so long, and some people listening to this, I'm sure, use Pro E. Probably a lot of people use SolidWorks, and there's similar programs. Are there any pro tips that you can share about how using one of these, I'll call it more mechanical design CAD programs, Pro E or SolidWorks, to create some of these complex shapes in CAD? It's probably kind of a tough question to answer without sharing a screen or something, but anything that comes to mind that might be helpful for those working on these types of shapes or products?
Yeah, I found that after 30 years of using Pro E, it could do the things that I needed unless I ran up against its fundamental shortcomings, like the geometric complexities that I was wrestling with. But I ended up doing lots of lofts and toroidal blends and boundary patches and things like that. It sometimes worked, but I think I yelled at the machine quite a bit for any success I got. It was a lot of
a hard-won success.
Yeah, exactly. It's really meant for designing the next 747 more than complex prosthetic limb or something to that effect.
Yeah. Okay. Well, you were the design director at 3D Systems for several years. Can you share some of the products that you helped develop during that time?
It was a really interesting time at 3D Systems because it was transitioning from a company that made big industrial equipment that got stuck in a garage, which is traditionally where 3D printing was back in the early 2000s and 2010s. They were transitioning toward becoming more consumer facing. And even their industrial products wanted to really step up their game because it was becoming a competitive market with EOS and Stratasys and some of the other big 3D printing companies coming along with beautiful products. So on the one hand, we were charged with coming up with the design language, the color texture callouts, radius callouts, things like that. They created a cohesive design language and brand language among all the products, from $1 million metal printers down to desktop consumer printers. There was some of that. And then also the company decided that it was going to get into consumer in the mid-2010s period. And that is a bold venture for an industrial company. So we had to really look at how we're going to get this kind of unfamiliar product at the time, a 3D printer. A few FDMs existed at the time, but it was a pretty new toy on the scene. How we were going to get that usable and easy and comfortable to an entry-level consumer. So we put a lot of energy into that as well. And then in the other direction, we're also a skunkworks. So we would get tasked with all of the weird things that nobody else in the company could address. It was a very engineering-heavy company, so we were the sink trap. When somebody would come down the pipes and say, hey, can you 3D print an acoustic guitar? Can you 3D print the sound that a dolphin makes? Can you 3D print this weird thing that this weird, black operations group in the military is exploring? Can you do that? Can you look at architecture? Can you do ceramic? All this stuff. It was my little team here in San Francisco, and we would get this crazy project in our lap, and we would just drop everything and hack it. So we were kind of design hackers during that time.
That sounds really, really fun. I mean, was it just a blast working there, or does it sound great on the outside, but really it was just like impossible project after impossible project?
The cool thing is I had a fantastic team, and they're all industrial designers, and they all knew multiple softwares, and they were all hungry for more weird stuff. And nice. If there was any resentment in the team, it was because somebody got a weirder project than somebody else. And so they were jealous because they didn't get a weird enough project thrown in their lap. That's just the kind of personality that I sought out. And it's certainly the kind I got. And that made it fun for everybody, that there was such an eagerness to take on really unexplored territory and see what we could do. It was fun. It was highly stressful, of course, because we were doing it under the gun. I was on the airplane once or twice a week. And it was, there were plenty of failures, plenty of times where we had to just throw up our hands and just say, well, this is as good as we're going to get because the technology isn't going to get us, so it was all over the place.
Very cool. Well, it sounds like an exhilarating environment in which to work. I guess when you were at 3D Systems, you also worked, I read, with will.i.am of Black Eyed Peas and several other things that he's done over the years. But what was that like? How did will.i.am even find his way to 3D Systems, and like what were you guys trying to accomplish together?
Yeah, Will was kind of an unexpected surprise guest who stayed for a couple of years. The company 3D Systems was run by Avi Reichenthal at the time. And he was a very bold CEO, and he wanted to create certain chemistries that were very unexpected. And as we, 3D Systems, were getting into the consumer play, he wanted to have a really iconic consumer person to stand out there and tell our story. Will was great because he's super charismatic, very smart, but also he has an accessibility to him. He's a very friendly person, and he loves technology. And so he was kind of the out-facing face of the company who showed people that here's this new weird tech coming, and it's really cool. And so it was a lot of fun working with him too, because he has a very young spirit. And we were down at his lab in Los Angeles. It's a city block by a city block lab called The Future. And it's this amazing place with sound studios and green screen studios and it had a fantastic maker lab in it where he had 3D printers and all kinds of stuff going. And so we did a lot of brainstorms down there with him.
How cool. Do you remember any of the projects in particular that you guys collaborated on? Anything stand out as being particularly interesting or successful?
Yeah, one of the products we did with him, I designed the Cube printer, which was 3D Systems consumer FDM printer. And then we reinvestigated it with Will and decided, okay, let's make it a high watermark of environmental forward thinking. And so we went over piece by piece to see how we could reconsider it through that lens. So, for example, it had this internal part, a visible kind of lens part that was backlit. We decided, let's make it out of the red material recycled from automotive tail lights, because this is beautiful, consistent red, I believe either acrylic or polycarbonate. And then the material that it printed was PET, was rPET, recycled PET, which turned out to be a great material. And we had a deal, I guess, with Pepsi for a while to take their recycled bottles and turn them into filament.
Oh, cool.
So that was a Will project right there.
Nice. That's very neat. Huh. I looked at that cube as I was preparing for this episode, and one of the things that struck me, just a design choice that you and your team made, was there's this covering the filament spool. I think that's what it was. There's kind of a frosted, I guess it's like a polycarbonate, probably something like that, frosted clear material, and just the fact that it was frosted, so it kind of blurred the material spool inside of it, was such a striking cosmetic, and I really, really liked that. It just to me, it seemed like a very cool design choice.
Thanks for noticing that. That was a very hard-fought battle, and this speaks to your first question about how industrial designers and engineers relate, because there were people in marketing who said, wait a minute, the case has to be opaque, because otherwise people will see the material and they will they'll see how little material they have left, and that's a bad marketing decision. And so we in the industrial design team said, wait a minute, if we make it clear, you can see the color, you can see how much you have left, you can watch your spool deplete so you know when to buy another one, things like that. And it doesn't seem like that should have been such a hard argument, but it was, because it led to all kinds of marketing decisions that we had to second guess. So that's kind of typical with the corporate world, is there's a lot of arguments for every achievement.
Yeah. Oh, how interesting. It's interesting to hear the behind the scenes story of how that went down. But just from a visual cosmetic aspect, I loved that feature. That's what stood out to me when I looked at the cube. I really, really liked how that turned out. Wow. You spent several years as an advisor to a group called Make in Space. What were some of the goals was it Made in Space or Make in Space?
Made in Space. Yes, Made in Space is a trick off of Lost in Space.
Ah, okay, got it. And what were some of the goals there, and how did they take shape over the time?
Yeah, Made in Space was a really unexpected, interesting group. I was lecturing at Singularity University, which is a very forward-thinking. It's like a Chinese menu meets a TED Talk, a really interesting place. And some of my students came up to me and said, "Hey, has anyone ever 3D printed in space or in zero gravity?" And we said, "Well, as far as anyone knows, no." Strangest question. So then they said, "Well, is it possible?" I said, "Well, probably not with an SLA and probably not with an SLS. So that leaves an FDM. Let's see what we can come up with." So we flipped a machine over. Well, first we went out for cocktails, and we had a lot of margaritas, and that, I think, predicates a lot of innovation, typically. And so we then did over an FDM and rubber banded the plate into place, and it printed great. In fact, the characteristics were unchanged, upside down or right side up. And so,
interesting. Huh.
Yeah, so that then led to them getting some funding from NASA, and we brought on, I was made one of the advisors, and they brought on another advisor, a great guy named Dan Barry, who's a multi-trip astronaut, and a guy from Autodesk named Gonzalo Martinez, a wonderful, brilliant guy from their office of the CTO. And so we talked about why you would 3D print in space first, which, well, one of the reasons is that they don't have resupply up there. Resupply is extremely difficult. And they do a lot of stuff ad hoc. There's a lot more duct tape and baling wire than you would expect going on in the ISS. And then it makes a lot of sense. If you can ship raw material up there that is packed 100% dense and do your fabrication in situ, then you are making much better use of the space that you are, or the volume that you are hauling up to the ISS. So it just made sense from a lot of levels. Then the challenge was to create that printer. So the guys in space, they spent a couple of years, and the time wasn't all that hard to build a printer. It was really to qualify the parts and the materials in the printer, because the ISS is the most regulated piece of property on Earth or off Earth. So they said pretty much you have to qualify which mine the metal to make a machine screw comes from. It's a little bit of an exaggeration, but it's because it's such a regulated environment.
Wow.
And then a 3D printer up there that has thermal characteristics and off-gassing and everything else, everything gets weird in a contained air environment.
Yeah.
But in my job as advisor, I decided the weird thing I would do is request that they provide Tang at all of our advisor meetings, because that's the spirit of the And so they tracked down Tang, and then we decided it doesn't even taste very good. And then Dan Barry, the astronaut, said, actually, that's not true, that astronauts don't drink Tang. That was used once for a promotional thing for Tang in the 70s. And then after the one mission, they stopped drinking it. So much for my being an advisor.
It tastes so bad.
Since the machine has been up there, they've made 2,400 parts. So it is in regular use.
Oh, really?
Yeah, and then the Russians built their own version, and it blew up on the launch pad. The rocket didn't make it 50 feet up. Oh. And then the group then was given $100 million from NASA to print outside the craft, which is much harder because you have extreme thermal characteristics, radiation, micrometeorites, all these things. And I haven't talked to them in a while, but I suspect that's where their energy is going right now, because you can build potentially megastructures, multi-kilometer structures in space if you're printing it and hauling up simply raw material. Yeah.
That seems like a great candidate for building, space stations on Mars or the moon, things like that.
They can print from a meteorite because they have a lot of iron and nickel in them. And so there was an exploration to see, can you capture a meteorite, grind it up, process it, and then print a part out of that meteorite?
Oh, how interesting.
And we proved that, yes, you can.
Wow. Very cool. Well, I'm going to take a short break here and share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. And we're speaking with Scott Summit today. So, Scott, it seems like 3D printing is kind of your niche within design. Why did you gravitate so strongly towards 3D printing? And looking back, would you choose that same path again?
It's interesting because I didn't gravitate to it as much. It was simply a means to an end. I gravitated to challenges, mainly to looking at how to create a 3D printed or a prosthetic limb that was of higher quality and that represented a level of design that was inachievable any other way. And I looked at different variations of thermal forming, vacuum forming, pressure forming, short run injection, things like that. None of them were going to get me to where I wanted to go. And so 3D printing seemed to make a lot of sense. And it opened up a lot of doors because it showed the versatility that is inherent in a 3D printed design process lets you create something for an individual in a way that you really can't any other way. And that back in 2007, that was a fairly radical idea. Now it's becoming more the norm and increasingly so. But back then it was pretty exciting to see that you could, instead of designing something for millions of people, which is what a typical industrial designer does, you can design for an N of one. And that's a very different frame of mind that you take into that equation. It's more like a craft, a traditional craft or a bespoke craftsmanship. And that, I thought, was a really interesting hybrid of disciplines to explore.
Having so much experience using the 3D printing process, can you foresee any types of innovations or advances in the next 5 years or so? Especially since you were working at 3D Systems as well, I'm sure you had some behind the scenes visibility there to developments that are going on. But anything in particular that you see coming in the next 5 years or so within the realm of 3D printing that's really going to make another big leap in how we make things?
I think 3D printing is going to continue on the trajectories in every direction that it has been going, and that alone is exciting enough. For example, 3D printing architecture, that is happening. And if the regulations ever catch up with it, it's a highly regulated industry, then it will really come into a life of its own. It's very nascent. It's really exciting to see what's going on. Especially if you look at like what is happening in the Netherlands and what MX3D, Joris Laarman's group is doing out there in Amsterdam. There's amazing stuff in that category. And then you had a guy on a few weeks ago who was doing patient-specific design, 3D printing patient-specific parts for exotic surgeries. That is pretty stunning because all of a sudden doctors have a new tool that can save lives and address medical needs in ways that were never before possible. So that's really cool. Printing for micro devices, so devices that are extremely small with this different new types of printing. That's exciting. Printing shoes on a custom level. We will see that so that when you buy your shoes, they will be made for your body and your gait and any idiosyncrasies that you have. I'm really looking forward to that because that will solve spinal issues and things like that. And then I think that the thing I'm most excited about is that it will continue to be increasingly a device for groups like high schools, grade schools even, because what that does is it gets kids excited about the iterative process, about the try and fail process, which I think leads to ultimately a generation of designers and innovators that is a cut above our generation, because they had these tools at their disposal from day one. And I think that gets especially exciting.
Yeah, absolutely. Um, uh, Speaking of spinal conditions, you've done quite a bit with prosthetics and orthotics, particularly within the context of 3D printing. And for those of you listening, we'll include a link to Scott's website where you can go and see this. And I highly recommend that you take a look at some of it because it's really cool stuff that Scott has designed. Scott, can you talk a little bit about how you got into that space?
It was interesting. I was originally looking at 3D printing prosthetic legs because I wanted to create something that was a cut above what was available traditionally and what mass production could create. And so it created a process where you could 3D scan the person's residual limb, it's called the sound side limb, with a scanner that we invented because you couldn't do that with a smartphone back then. So we had to there weren't smartphones actually back then in 2007-ish. So we invented a structured light time phase scanner and a stereophotogrammetric scanner that could capture the body. And we worked with Walter Reed and Balboa and Center for the Intrepid because they had plenty of soldiers and they were interested in experimenting. And so then we created a parametric process where we could take that scan data, use Geomagic to clean it, and then 3D print the new prosthetic limb. So that I was very intrigued by because you could, using parametrics, create something that's both mass-produced as far as it is a automated hands-off process for the most part, but it is also custom per person. It's entirely bespoke. So that's why I named the company Bespoke. And then you can add a sense of beauty to it through the design and the contours and proportions and things that it wouldn't otherwise have. And it's not purely a cosmetic role that plays because you're trying to get the person to thrive, not just to not fall over when they walk. You're trying to really get them to embrace their body and their form. A lot of times you'll have people, I had one woman, she was a Boston Marathon victim. Her leg was blown off when the terrorists fired up the bomb. I wanted to give her a sense of her beauty back, and you can't do that using conventional methods. You have to see through the eyes of an artist to do that. And then the scoliosis treatment was especially interesting because the process as it stood before was that an orthopedic, actually a prosthetist, the guy who's making the brace, they would make a brace and it was a big chunk of polypropylene and they would wrap around the kid and they'd heat form it and things like that. It looked horrific. And the success of the process was predicated on getting a 12-year-old girl to do something she doesn't want to do for 20 hours a day for 2 to 4 years. You're not going to win that battle. You're talking about a little girl who does not want to do this horrific experience. And the only way you're going to do that is really hack and rethink that experience. So we created this 3D printing process where we 3D scanned her to create a digital twin. We offset the geometry, but also then we created a brace that looked more like lace. And it seemed to her more like lingerie and more like a bodice or a corset. And she got to choose the pattern, which really kind of framed the story more as fashion than as medicine. And so it was all about getting into the psychology of a 10 to 12-year-old girl and hacking how she thought of this experience that she was about to have to deal with for the next couple of years. And so we found that in that case, design and fashion, bringing that sensibility into the process made for higher compliance. And higher compliance means greater efficacy. So it was a strange process where medicine was impacted by design and fashion. And so the beauty of the product translated directly into the effectiveness of the medical outcomes. And there aren't a lot of situations where that was the process, but that made it especially satisfying and exciting.
That makes a lot of sense to me. I think about CPAP machines, right, where they're functional, but people hate using them. The experience is just so arduous and uncomfortable, and so they end up not using them. So there's a medically poor outcome because of the experience of using this product. And one of the things that struck me as I was looking at these orthotics and prosthetics designs that you have created was that they look like a fashion accessory, not a clunky medical device. And I'm sure these poor people were used to having to rely on something that was functional, but probably looked terrible. And so once your solution came along, and all of a sudden it's not just a functional solution, but it's something that's beautiful as well, that hopefully they're proud to wear, and it's like this really cool fashion accessory. How did people respond to that? Coming from the place of just having to put up with this functional but kind of ugly contraption, and then being presented with this really beautiful solution.
It was as successful as we had hoped, that girls suddenly started showing each other their braces, which typically is not what you do when you have this kind of something that looks like it came out of a Frankenstein movie. They started showing each other, they started showing it off. They're proud of it. I think the high watermark in that experience for me was when there was a 3D print show at the Louvre in Paris, downstairs of all places. And so we had the brace on display there. And a French woman was staring at it for a while. And she asked me in French, she said, "This is beautiful. How do I get one?" And I looked at her. I wasn't prepared to answer that question. And I said, well, and I'm trying to translate this into my bad French. And I'm saying, well, this is a medical product. It's for scoliosis. And I probably didn't translate that well. And she thought about that. And she said, okay, how do I get scoliosis? And I thought about that for a while. And I said, well, it's idiopathic. And I don't have a translation for idiopathic either. So we're at an impasse here. But it did say that, okay, we had reached our goal, which is that we had stepped out of the medical world and we had created a desirability as a fashion product, which reframed the question. It hacked it correctly.
Yeah. Wow. What an amazing feeling that must have been. You write on your website that I'm most excited by the products that result when a designer has relinquished agency in the process and product to a variable beyond their immediate control. The designer must willingly accept that an outside force will be co-designing their product, often leading to unanticipated and ungovernable results. Can you explain a little bit more what you mean by this, and if there's an example that you can share from your own professional life, that would be great as well.
Sure. I spent, I guess, the first half of my career doing injection molded parts, doing consumer products for Apple and whatnot. And everything was destined to be injection molded. And I found that was very unsatisfying at the end of the day. You spend all this time designing and building this great thing, and then you get these injection molded parts with their witness lines and their drag lines and sink marks and things like that. And it just wasn't all that satisfying. And when each one is like every other one, it feels like you've designed vanilla at the end of the day. And because you're not trying to appeal to one person, you're trying to appeal to the mass market. And you try to do the best you can. So you're trying to be the Madagascar real vanilla bean vanilla, so the high watermark of vanilla. But at the end of the day, you're still just in the vanilla constraints. And so I was curious of what happens when you break out of that, when you get more along the lines of a custom bespoke thing that is for maybe one person and one person only. And that's what I find intriguing. And when you basically say, I'm going to only have half of the agency of this process. And so for example, when you're 3D scanning a person for a prosthetic limb, you have no control over the first couple variables in there, which is the person's morphology and their personality. Those are variables you don't control. And then you get to pick it up and react to those and integrate those into a process and turn that somehow into a thing of beauty. But you can't really formulate the process in advance or the outcome in advance.
Something that I know a lot about is the price tag that comes along with custom. Do you think that in the future, we'll ever get to a point, I guess, from a technology standpoint, where we can truly afford to provide these custom bespoke solutions to people who want them, not just wealthy individuals who can pay a lot of money, but even third world countries where whoever it is, John Doe down the street. Will we get to that place, or is custom bespoke always going to be for the privileged?
That's a question I explored for years as well, looking at, can you do a prosthetic leg based on a scan, but with data that you then send to the cloud, it goes through a parametric model. It does automatically generated FEA and potentially topology optimization. And then it goes to a printer with some discretionary bandwidth and then prints it and sends it to them. That I was never able to achieve. I believe that will happen, and it has to happen because the number of doctors who can create a viable prosthetic limb is not keeping up anywhere near with the increase of limb loss in the world. So the challenge and that gulf only goes greater over time. So it has to be dealt with algorithmically, automatically, in some kind of exponential way. But we actually, in some ways, already have arrived at that. For example, Invisalign is an entirely 3D printed process, and it is, I believe, more affordable than traditional braces, and it's a largely hands-off process. I believe it's almost entirely automated, and so now we have a better product. Invisalign, if it's an option, is a more friendly process than the traditional wires of braces. And that was entirely enabled because I think they print something like 12.5 million unique products a year for those aligners. And it's all just happening on SLA machines that are in the dark in a lights out factory. And they just print, vacuum form, and send. And you get essentially a custom aligner, which costs a few cents to make, but it leads to better outcomes. So in one sense, we're there. I do think that before long, we'll have 3D printed shoes that are custom to us. I wear the Adidas version that are 3D printed, and they're wonderful. They're my favorite shoes. So I think that it's not long before not only will they be printed, but they'll also be bespoke, and that will be an automated process.
I don't think I've spoken with anyone to date who's worn a pair of these custom 3D printed shoes. What was the process like? Did you have to go somewhere to get your foot scanned?
So these are not custom. These are simply printed. And I think that the companies that are doing them, Adidas, New Balance, perhaps Under Armour, Nike, they are mass producing them as a way to start that evolutionary process off. Because first they have to figure out how to get the pipeline of this new product. Do people like it? Are the mechanical dynamics correct for walking? Things like that. And once they dial that in, then it's the next step. And what I've been arguing for years is that the shoe store of the future will have no shoes in it. Just like Uber owns no cars and Airbnb owns no buildings, the next shoe store will have no shoes, that it will simply be a gait analysis room. And you walk into the Foot Locker and you will walk on a gait analysis machine. They'll do mocap of you. You stand on pressure plates. They will do a 3D scan of your external morphology or your foot. And then your digital twin is created and you never go into Foot Locker again. You simply try on shoes with your digital twin, see if you visually like them from a scan of yourself, which, you're going to look in a mirror anyway. It's the same thing, but it's a 3D version. When you like it, you simply check it off and it comes to you. And it will be a shoe that will compensate for any gait issues you have. It will be essentially a custom orthotic. It will be designed for running or hiking or standing at work or whatever it might be. All those characteristics are just algorithmically folded into the design of that shoe. So I'm really looking forward to that day. For somebody, I've got occasional back problems. I'm looking forward to the day when my shoes are actually designed so well for me that they are corrective, and that's invisibly folded into the design of the shoe from its DNA outward.
Absolutely. What a cool future that you're describing there. Just maybe one more question, and then I think we'll wrap it up here. what are a few of the products or projects that you're most proud of, and what was their impact on the consumer or whoever the demographic was?
There were a couple of interesting products that we got involved with. Avi Reichenthal, the CEO of 3D Systems, asked if I could design a 3D printed acoustic guitar, do the first one of its kind. And so I did that. And it turned out to be, I thought, pretty interesting because we designed it around the acoustics. We worked with the Stanford Sound and Design Research Center there. We really dialed in the acoustics and it sounded fantastic. What I thought was interesting about it was that when I sent it out to all the guitar magazines, it got panned. People absolutely hated it because psychologically guitars.
Really?
Yeah. And I understand where they're coming from. They said a guitar is a thing of beauty. It's a thing of, you can see it on my website. I think it's fairly beautiful. Summitid.com. You can see the guitar. It's a beautiful thing, I like to believe. But they say, well, no, this is craftsmanship. It's a luthier working with wood and with their hands. And it can't be algorithmically generated and 3D printed. That's just not right. And so I thought that was an interesting outcome. And then it was actually stolen from the gallery space in our lab in Berkeley. Somebody ran in, grabbed it, and left. And so I like to think,
no way,
a little quiet, backhanded compliment there. Somebody just doesn't realize that they actually stole the first ever 3D printed guitar, and I took that as a compliment because I can always print another one. So that was a fun, silly one.
Great way to reframe it.
And then we worked with a company called Exobionics, which is founded by this brilliant roboticist named Russ Angold. And they want to ultimately replace the wheelchair with an exoskeletal robot that wraps around your body and walks you. And it's an amazing piece of machinery to see work, and it really impacts lives very profoundly. And so we worked with them to do an experimental show car of what their machine could be into the future. So we took one of their test pilots, a lovely woman named Amanda Boxtel, and we 3D scanned her, and we created the interstitial parts that connect her body to the machine. And we tried to make those really beautiful because this is a part of her body in a sense. It's as much her exoskeleton as her exomusculature as just a part of her symbiotic part of her life. And so we designed and printed that, and I guess in 2014 we took it out to Budapest to debut it to the world, and it was beautiful, and she loved it. And we walked all around Budapest with it, and it kind of brought tears to her eyes because for one thing, it conformed perfectly with her body, but also when she's walking, people see her as a person walking essentially with a fancy crutch, and they don't see her as a person who really is paralyzed from the waist down, has no sensation below her waist. So that was a very, very meaningful, very powerful product to be involved with emotionally and very challenging mechanically and design-wise.
I bet. Yeah. Wow. How amazing. What a wonderful, fulfilling project that must have been. Okay. Well, Scott, this has just been such a delight getting to talk with you and hear some of your stories. Thank you so much for sharing some of your background and time with us today. How can people get a hold of you?
My website is www.summitid.com. I'm on LinkedIn somewhere at Scott Summit. And then I have a new company out now. It's called Ethereal Matter. And we didn't talk about it at all. And hopefully we'll follow on maybe next year with it once we can get funding and go live with it. And it's at www.ethereal, ethereal-matter.com. And that website will give you a little teaser as to what it's all about. It's some pretty interesting stuff as well.
Great. Well, that sounds exciting. Again, Scott, thank you so much. Is there anything else that you think we should cover that we haven't talked about yet?
No, I'm just especially appreciative that you are doing a show speaking to engineers in particular, but from the vantage occasionally of an industrial designer or somebody who's a little bit out of the immediate world of engineering, but certainly connected to it at the hip.
Well, thank you. Yeah, we're all part of the same big happy family, aren't we?
Indeed.
All right. Well, thank you so much, Scott.
Great. Thanks, Aaron. It's great talking to you.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.